So kindly turn off your cameras and microphones. We will now proceed with the talk. Dr. Ali Nadir Arslan, the floor is yours.
Good morning. Thank you very much for nice introduction. I think, do you hear me well?
Yes, very well.
Okay, so then I will share my presentation. Let's see that we will be successful on that. I just made a full screen now. Everything is okay?
Yes. Can you make it full screen, please?
Yeah, I made it. Probably it will come. It's not full screen?
Not yet.
I can see the full screen, but this is full screen on my side. Not yet? So you don't see a full screen?
No, not yet.
Okay, so
we can
stop.
begin, and our IT is coming for support.
Let's see if again, like this. How about now? No.
Yes, now we can see the full screen.
Thank you so much. Perfect.
Thank you.
Good. All right, let's start. Thank you very much again for inviting me as invited talk. It's my pleasure to be here, and also I'm now also now we are making hybrids, so we have here also the in-room. So welcome to also my presentation and also remotely. So I'm going to talk today. I think I've been well introduced, so I don't need to introduce more. So I'll try to give you some thoughts about these opportunities of Earth observation in the official statistics, especially the smart statistic. So if we success this, then everything goes well. So I'm going to talk about, give some information on a little bit background on this use of Earth observation in the statistical world. And of course, I will not only background, but I will talk about a little bit about this, the use of the Earth observation, and then what the National Statistic Office are needing and what they should be evolving. And I will also give a little bit about this UN, sustainable development goals, and relating to the statistics that they're driving. And then once we have this understanding of this statistical world, then we will be looking at this, what are the opportunities of this in European perspective. So because in order to implement these things, that we need to have this space or big data, which is this, we call this Earth observation data. So Earth observation data, we are talking about actually two components. So it's an in situ and also space component. So they are both considered as a Earth observation data. So why this is related with the statistical world, and also because space data is considered as a big data. So that is now a lot of data is coming up. So that's why I would like to introduce a little bit about this. What are the European space capacities that we can utilize this Earth observation into this statistical world? Then I'm going to give some information about this the project we have completed a year ago. So related with this Earth observation into the use of statistical world, just giving this an idea that how this could be in practice can be implemented. Let's start with this, the little bit background. That's actually, of course, this statistical world and Earth observation goes back on this Warsaw Memorandum. But at the 47th meeting of the European Statistical System Committee, which they call now Warsaw Memorandum, on that the Earth observation for official statistic was adopted. So there are quite many item has been considered. I'm not going to read this, so I hope that this will be shared, but I will provide these highlights of this to you later in a minute. So there is this, just at this point, you need to know that there are the committee, there is this memorandum of understanding, which is Warsaw Memorandum by the member states, and then they've been accepted. The Earth observation for official statistics has been recognized. Then Director of General of the National Statistics and Eurostat, I will explain that if someone doesn't know that Eurostat, they have basically agreed on these 13 points that I'm not going to repeat this, which I'm going to get the highlights of this. So this is just a background. So what these two of this, what is the memorandum of saying? So basically, please have a look this in detail later, but this is just some highlights that I've been thinking that it's kind of summarized. So it says that they make extensive use of Earth observation data in official statistics, and Earth observation for monitoring and reporting for SDGs, Sustainable Development Goals, indicators, for agriculture and maritime statistics, and for other relevant domains, and develop the use of Earth observation in statistics and gain skills in the use of technologies, implement an integrated European strategy for using Earth observation in different statistical domains, enhancement of cooperation between Eurostat, national statistic institutions, European Space Agency, international organization, national space research centers, state agencies, mapping agencies, policymakers, scientists, private companies, make the full use of Earth observation for official statistic purposes. Develop a standard methodology for processing, analyzing, and validating Earth observation data. Open, sustainable, and interoperable infrastructure for analysis-ready Earth observation data for multi-purpose use at local, regional, national, and European level. And also use of high resolution and frequently updated remote sensing data via satellites for official statistical purposes. And finally, I think this is now this daily routine that we are all implement this AI, strengthen the use of artificial intelligence and ontology of AI in terms of Earth observation, because I think AI is now the must that if we deal with the big data, such as also the space data. So these are some highlights of this Warsaw Memorandum. These highlights showing that actually the Earth observation has been recognized as a new data source for the traditional statistical. So this is an idea. Of course, we will see that how this will be successful. Just giving a little bit information about this, if some of you are not familiar with the topic statistics, which it's not my expertise, of course, I'm coming from the Earth observation, so I had to understand many things also about this statistics. So Eurostat is the statistical office of European Union, and then chairs of European statistical system, and also this working about this 800 staff, which is located in Luxembourg. So basically, it coordinates all this European statistical system, where there's all this national statistical office are the part of this. So this is just the side information. And what are so we have this Warsaw Memorandum, and we have this that things to be done. So what are the expected actions should be taken? So for instance, applications such as pilots, proof of concept, and prototypes. And that's why using scaling of this European statistical system level, that's why actually we've been running this ESA Gauss project, which is the part of this initiative fundings. And the skills, of course, they are required, they need to develop the skills and identification and necessary skills and course programs. And methodology, there should be methodological guidelines, solution for analysis and validation of production processes, methodological guidelines, solution for harmonizing data sources for the production processes. I mean, this production process means, of course, statistical, the information, because they are required. And of course, toolbox, the tools are needed for the methods and cloud-based services along with reference implementation as open source code modules. And also the collaboration with the stakeholder to collect the best practices, developing common understanding and setting up of interdisciplinary network. An inventory of action, conclusion, recommendation. So I hope that I tried to prepare my presentation giving information, but at the same time, I think one of the idea that to give this, the direct you the future area that where you could actually work of this as a network excellence of current work. So it could be interesting for you to which direction to go. So, and the training, of course, that's very important because from the strategies to practical use of Earth observation data for official statistics are very important. And then advanced Earth observation for official statistics, big data tools for IT professionals supporting the statisticians, because they are two different worlds. It's bringing the two different worlds, of course, is a challenge. And integration of statistics and geospatial information from geocoding and statistical maps, and automatic identification system vessel data for application to maritime, flowable statistics, source tools, and methodologies. I mean, it's not like one day to other day that things has to be solved, but there are a lot of things to be done. So here I wanted to provide you a little bit about information on this, where actually these are also going back. Why? I mean, why is the official statistics, national official statistics actually doing the work? Of course, there is one thing that of course the national level, they want to understand this, but there are also the higher level, we are talking about this sustainable development goals, in support of sustainable development goals. So this is the main, one of the big driver. So basically, we all know about this 2030 agenda with 17 sustainable development goals and 169 targets and a global indicator framework, presently consisting of 232 indicators, which is the 2030 agenda require us consider new and innovative means to curtail the many development challenges in order to leave no one behind, and with the commensurate new and innovative data sources and methods. So basically, as the data sources, we are now talking about the Earth observation. And you can already see here, I don't know if I move my cursor, if you see it, there's this Earth observation and monitoring has been already put in the system, that how this actually then, how things can be now from the bottom pyramid type of pyramid to go up. So this is one of the things that one of the big driver of the sustainable development goals. So how Earth observation data can help? So Earth observations offer unprecedented opportunities to modernize national statistics system and improve the capacities of countries to efficiently track all phases of sustainable development. So which we just previous slide has been addressed. So satellite data has a role to play in relation to most of the 17 goals and around a quarter of the targets, because there are many targets. So provide accurate and reliable information on the state of atmosphere, ocean, coast, rivers, soil, crops, forests, ecosystem, natural resources, ice, snow, and built infrastructure, as well as their change over time. So effective use of the information from satellite observation can have a transformational impact on many of humanity's most significant challenges, such as helping monitor and protect fragile ecosystems, ensure resilient infrastructure, manage climate risks and public health, enhance food security, build more resilient cities, reduce the poverty, and improve the governance, among others. So this is all this has been addressed in the Sustainable Development Goals. So once we apply this satellite Earth observation data for the Sustainable Development Goals, what are the key benefits actually we are having against the indicators. So this can be categorized under 3 categories. One is this satellite Earth observation data makes the prospect of the global indicator framework for the Sustainable Development Goals viable, such as for many indicators, the coverage and frequency of measurements from which the indicators are derived would simply not be visible technically or financially if satellite observation are not used. I'm going to talk about this coverage and frequency of this which satellites are providing, the future, what it means. But we know that, of course, this basic principle of remote sensing data, because first thing we teach the students what is the advantage of remote sensing is, of course, with this coverage and frequency. Of course, that is the one thing that that's a fundamental thing. And the other one is the potential to allow more timely statistical outputs. What it means, reduce the frequency of surveys, as this traditional statistical office are doing, and to reduce the respondent burden and other costs, and to provide data at more disaggregated level for the informed decision making. And third category we might list as key benefits of the Earth observation in the Sustainable Development Goals: the improved accuracy in reporting by ensuring that data are more spatially explicit. To support the evolution from traditional statistical approaches to more measurement-based solutions, as some challenges, including in relation to environment and human populations, become more pressing. And that's why with the need of we need the more accurate, spatially explicit, and frequently updated evidence. So this is another key benefits that we can receive from the Earth observation data. So what are the characteristics of which I've been now talking about this Earth observation data, the characteristic? Like we are now talking about this public and national satellite data. Of course, we have this commercial satellites which you need to pay. But free and open, that's one thing that we have the European, especially Copernicus program, and scale and coverage. So it means that you can have this Earth observation data every scale: small scale, regional, local scale, regional scale, national scale, and European and global scale. And consistency and comparability. What it means? Because the consistency, because let's say that if there are surveys going from this statistics, there are all this the individual based surveys, but in this Earth observation, there is only, if there is an error, there is a systematic error, and there is a comparability because you can compare with this different region because it's the same data that you are receiving. So it can be comparable. So this is a very important in the data analysis. And another important thing is continuity and time series. So basically it's a continued data, and then you can have the time series of the data in a back to go or whatever future. So that is the one thing. Complementary with the traditional statistical methods, and the diverse measurements. So diverse measurements, which means that we have different technologies. We have this microwave. As you know, that there are lots of the sensors, like radar, optical sensors, and there are different frequencies and different polarization and different resolution. So they have a different measurements techniques that it has been implemented, so we can receive it. Of course, having said that, so these are the good side of the Earth observation, but in practice, it's not an easy task. As we all know that new things require changes, and these changes are not always the possible. I will tell you in our Gauss experience that, especially working with the governmental organization, the changes are almost impossible or very slow. So and challenges that, as always in this part also, that first of all, let's go that what are the needs of the national statistical offices, or what they need to evolve future, what they should do, what they are, what is the stakeholders required from National Statistical Office. The stakeholders, like us as also the citizens, and also the other policymaker and everything, all like that is UN, they are requiring more open, easily accessible, timely, quality, and granular data. That is the requirement now that National Statistical Office has to go through. And ability to combine data from different sources and develop new statistical models. That is also required from the National Statistical offices. And new data sources often require new expertise. It means that they need to build the new expertise in these statistical offices, and supportive regulatory frameworks that are built on trust with data privacy and ethics at their heart. So, you know, now we are talking about the drones, and you know that drones are very problematic now. In the European Commission, they're trying to make a standardization of use of drones. So such as things for drone can be considered as a near surface remote sensing data, not satellite data, but near surface remote sensing data we call. So the challenges we can classify under two categories. One is the big data, and the other one is standards. Basically, big data this is a typical the challenge that its size, growth, and dynamic characteristic of big data are different from the features of traditional data sources such as surveys, censuses, and administrative data. So they are comparing of the very big differences. Because additional procedures and infrastructures for accessing, transferring, storing, processing, and analyzing big data are needed in this National Statistical Office. And standards, another thing, because National Statistical Offices must adhere the standards to frameworks for producing the official statistics, which require rigorous and comprehensive checks and quality assurance. So that's because that must be done. It's like a military. So if you make an error, it cannot be accepted. So for instance, I just wanted to share one example from this. I mean, this is not my example. This is I took the satellite. My reference is on the right back. You can see. So this is the Mexican the statistical office that integrated use of geospatial Earth observation information and statistics to monitor national and global indicators. So you can see here that four categories like satellite imagery, other sources, national users, and which SDGs, Sustainable Development Goals, and other applications that answering. So I think this was 2016 or 15, very old, but it's most of the people are presenting this because it gives you very good information. I hope that you can also create such a table that in what is answering your own need. So why I said that, because there is no Sentinels, there is no, our European satellites are here, so that's why I said that. So there is this satellite imagery, and there is the other data used, and then what are the application, and then I think this is a very good kind of the overview example to see it. But we will go a little bit more deep on this. So I tried to create a checklist kind of for decision on use of Earth observation data. So I mean, this is the very quick checklist. You need to go more detailed, but in my opinion, this is somehow gives you an idea that what can be used. So a first question should be asked that what is the necessity in our problem? I mean that we are applying. Is use of Earth observation data justified? So that is the first thing that we need to look at. And the other one is that the applicability. Is this the one that the Earth observation data we are aiming? Is it applicable or suitable for our targeted products? I mean, whatever this statistics that we are looking for. And spatial resolution, we need to think that is this spatial resolution that it's enough for our application that we are looking for. Uncertainty, what is the accuracy needed in this targeted products? I consider this statistics office also the services as a product. And temporary resolution, so how often that we want this data available. And then the availability. So what is the timeline we want to have this data? Is it 10 years back? Is it 5 years back? Or is it 10, 20 years back? Or is it how? And of course, there's a very important question is that continuity. So because if you create service, you need to guarantee that this data will be available in the future also. So that is the important. So this is kind of the little background of this, just getting this, setting up the ecosystem of the statistical. So, and now I want to go next to that, what is the available data that we can have, which is the Copernicus, of course. I think I have seen some catalogs here, the Copernicus, so you must, maybe this group quite familiar. I don't know the guests on the remote, but just I don't want to give deeply, because I can talk about this Copernicus services an hour or more, which I've been talking usually, but now I picked up a few slides. So if you are still did not hear about Copernicus, now you will be hearing. So that is actually, I'm the delegate of Copernicus user forum. This is one of our mission is to tell about the Copernicus program as many public as possible. So we call this Copernicus is European eyes on Earth, looking at our planet and its environment for the benefits of European citizens primarily. Of course, now the Copernicus program become a global program, but of course, since we are European citizens, we are paying the tax. So this is the primary for the European citizens. So Copernicus is a European Earth observation program, and basically European response to global needs, such as to manage the environment, to mitigate the effects of climate change, and to ensure the civil security. And it has been long programs. I mean, we already started with the 98 with the Bavarian Manifesto. Now then, actually it started with the GMES as a global monitoring environment security, but then we adapted to change the name, the 2011, the Copernicus, biggest scientist, that has been changed. And then not only data, but also now we created Copernicus service, operational services. So which I'm going to talk about. So the Copernicus is a global system view by the Earth. So basically, these are just the highlight of these global parameters that we are monitoring: chlorophyll, sea level height, sea surface temperature, soil moisture, carbon dioxide, and nitrous oxide, which is very important for the climate change and also for other applications, but not like that. So Copernicus has two vertical component and one horizontal component we call. As I said, that we have the space component, we have in situ component. So in space component, we have not the Copernicus satellites are considered specific satellites or European satellites called Sentinels, which is the Copernicus satellites. But we are not only utilizing the Sentinels, we are also calling the contribution missions, which actually the European Space Agency and European Union has been agreed on this public and other public countries such as China, such as America, such as Japan or Canada, their satellites, and also the private sector such as the Pleiades, Deimos, Terasar, Metop, and so on. So they are actually combined this group of the space component. And in situ component, because the Earth observation, not only space component, we need also in situ component. in order to validate the products that we are creating, or in order to create these new algorithms, issue data is also needed in model development. So these two are the vertical components. And then we are considered the horizontal component, which is we call the information and operational services. We have 6 Copernicus operational services that integrating with these vertical services, which is land, atmosphere, marine, the climate change, security, and emergency management. So 6 services. And these 6 services are entrusted by the European institutes. For instance, space component is entrusted, I mean, all programs owned by the European Commission, European Union. But then the European Union, because sometimes there is a big mistake that because the ESA, European Space Agency, has been advertising a lot, so people might think that this Copernicus is owned by the European Space Agency. It's not correct. It's this the European Union own everything, but European Union is entrusted to the other institute. For instance, European Space Agency is entrusted by the European Commission on implementing the satellites and operating the satellites. So that is their job. And also EUMETSAT, we are now in the picture. In Copernicus service, and institute component is operated by the European Environment Agency. They are in the coordination of this institute component. And other Copernicus services, such as land, there is these 2 entrusted institutes, such as the European Environment Agency and an EU Joint Research Center. They have own. Marine is Mercator International Ocean. Atmosphere and climate change is entrusted by the ECMWF. And then also the emergency management system is a Joint Research Center, and security with the EMSA. By the Portuguese authorities. So this is the in here. I think this is what I've been mentioning. All this coordination and what I said, and then these are the satellites, that Sentinel satellite that we have, and there's now 6 Sentinel satellites that we have this, and you can get the data free and open. Sentinel-1, Sentinel-2, and Sentinel-3, it goes like this. And then we have also the future expansion missions now in pipeline. We have these 6 expansion missions of Copernicus program is in pipeline, such as this Copernicus anthropogenic carbon dioxide monitoring, land surface temperature monitoring, which is the LSTM, and CHIME, which is this Copernicus hyperspectral imaging mission for the environment, ROSE, which is the L-band radar for observing system, and CMR, which is the Copernicus imaging for microwave radiometer, and CRYSTAL, which is this Copernicus polar ice and snow topography. So what I want to show here with the also next slide, that this is the ESA developed Earth observation missions in 3 categories: science, Copernicus, and meteorology. So we do have the data available that we to be used for this, I mean, for many purposes, but now today topics is the statistics, so we are talking about this statistics. So this is the data. Then also, which I mentioned, that 6 Copernicus services, actually not only data, but also products and models is freely available for you. So you don't need to develop your own model or products. Of course, there is a data, you can do it, but you can also use directly the developed ready product, which is huge of the entrusted and to develop for us. So you don't need to go and through, but you don't just, and also you can repack these products and add your own competency, and then you create new products. So there are the huge data sources that can be used for the statistics, for other applications, but now for the statistics. And there is now recently set it up this new the data access system where you can access data, not only data but also for other like tools and Jupyter's and open Earth observation editors and all this kind of new system that's called this Copernicus data space ecosystem, which you can use. So now with this, we are now covering this second part of my talk, which is now first I introduce you the statistics and the needs behind of it, and then second part I try to introduce very shortly about where this Earth observation data available and what is available to be used in this statistical work. And this is not only the data system that there are plenty of other data sources that you can access the data. This is the main part, but you can also go all this Copernicus services site that you can access the data there. And also ESA has been developed this DIAS system, Digital Information Access System, which is 6 DIASes are developed, and they are based on the company, so they are still, some of them still working actively, such as ECoE, which is the ECMWF AMETSAT collaboration of data access system. You can go there and you can also access. So there are many things. So in last part, I would like to now give you our experiences with this the exercise. So which I've been trying to explain you in 2 parts, in the statistics and Earth observation. So now I'm going to tell about you how we combine these 2 things in one of the ESA project. I hope you are still alive. So always it's difficult to run this 1 hour talk. Okay, I hope that this is still interesting and you're still listening me. So I think this is the most interesting part. So, all right. So I'm going to now explain you the Gauss project, which is this smart statistics, Earth observation for smart statistics. So this is actually the call that we answer, which is October 2021, answering the European Space Agency ITTs for Earth observation for smart statistics. So this is as I explained at my talks in the part B, that there was lots of pilot application ITTs will come. So actually this is the part of the reason that now this ESA and the Eurostat and doing this calls. Actually, this is very close to you. So because our coordinator for the National Observatory of Athens, so I was from Greece. And then we work with this. There was this 3 official partners: the National Observatory of Athens and the Finnish Meteorological Institute, and then the Polish side Institute of Geodesy and Cartography. And also we have Evenflow, which is from Belgium, the consulting company, which is actually putting all this application together and project management. And together with this, the stakeholders, because in this call, there's the statistical office has been asked to be part of it. So there was this Greek Elstat, I remember, I think correctly, that and then Statistical Poland and Statistical Finland. And in Finland, this National Statistical Office works different way than others. So we have this Statistical Finland on top of it. But then there are all these other government institutes are responsible for providing different statistics, such as, for instance, ECoE is the Finnish Environment Institute. So they are responsible of the water statistics to provide the Statistics Finland. So Statistics Finland are not doing, but the Finnish Environment Institute are giving them responsible. For instance, FMI, we are responsible for like numerical weather prediction or other type of the statistics, air quality and so on. We are providing. So Statistics Finland is not working as this other statistical office. So they are basically providing the work in others. So in this project, the Gauss project, so basically we are aiming to enriching the Earth observation and statistic convergence. So there are some kind of reasons that I explained you in my part 1. So what are our objectives? Demonstrate that how AO Earth observation data can help meet the key reporting needs of national statistics offices, and showcases to added value, showing that Earth observation brings in current or new workflows and introduce the innovation. And then some of the support these sustainable development goals indicators, which is listed here, and elaborate a future roadmap with recommendation for further integration of Earth observation in smart statistics. So, and this is the kind of the overall picture that we have these 4 use cases in this project. The air quality statistics using multiple Earth observation platforms was this use case by the Greece, which is the Greek partner. And our Finland, we have 2 use cases. One is this enhanced sparse statistic for snow, because of nature of course, the Finland, we are very Cryospheric component in country. And the other one is hydrological drought statistics, which we collaborate with the Politecnico of Milano. They were subcontracted for this work. And then Polish partner was dealing with the green indicators for well-being. So I try to explain this in each use case very short. The rationale of these the use cases quickly. The air quality is like obtain high resolution statistic for key atmospheric pollutants captured underrepresented areas, such as local administrative units. And then snow case, like statistic on snow cover and snow melt, are used to support decision in a wide range of fields, from transport to energy and tourism. And hydrological use case was to improve the monitoring of the water resources availability using advanced remote sensing techniques. And final one, that the Polish use case was aiming use Earth observation data to improve the quality and timelines of the regional well-being statistics, while assessing the transferability of the methods developed for other countries. So let's move as time is running. So this is the air quality. As you see here, I just wanted to very quick presentation on. So the current use was they were using only the National Air Pollution Monitoring Network as the National Statistical Office that's reporting. And on this, the particles matter, like this PM and nitric oxide and oxidide and so on. And in this use case, our Greek partner integrated the Copernicus Atmospheric Monitoring Service, which is regional assembly reanalysis, and nationwide network of low-cost PM sensors, third-party provider, which is also that was required of the call, and also the Copernicus Sentinel-5P tropy data has been used. And as you see that this is the first graph on the bottom right. Do you see my cursor, by the way? When I move, you don't. Okay, so then I have to tell. So on the bottom right, there are 2 images, as this with the red arrow. So basically, how we developed that actually from first picture, and the second one, which is more detailed, local administrative unit level, the information has been completed. So a little bit further, so these are the Earth observation data has been used, a data set that we have been using in this use case, I mean our Greek partners. So I don't have time to go all this, but I hope that this will be shared. And you can see here concept of workflow of Greek air quality use case. So actually you can see from the top left that how you can see the blue arrows actually showing that how this system is working, which direction. So we have this integration of Earth observation platforms, a regulatory network, smart sensors network, Sentinel 5P and CAMPS regional assembly, and then estimating that local administrative level or NUTS level aggregation output. And also they developed this GIS web interface for this statistical Greece LSTATS requirements. And here you can see actually that mean monthly the nitric oxide concentration for IPR reporting zones left, which is they are currently reporting, but on this right, you can see that this been developed from the local administrative unit level, this data that using these CAMS values. And here you can see the web GIS portal of the Institute and modeling workflow for the Greek use case. So basically, they developed this GIS portal where you can see the values in the local administrative level. So this was the Greek use case, and then if we move on the Polish use case, mapping extent and condition of green areas. There were this Polish use case for determining the two product, which is the extent and condition of green areas based on the satellite data represent a novelty in public statistics. And yeah, there were other works, but I think this was the main works. So here you can see the what data, Earth observation data actually has been used. This extent of conditional vegetation statistics generated based on this all these data, like plant phenology index, total productivity, dynamic world build classes, sentinel, and so on. And then for this each database that topographic objects actually for each this local administrative unit for Polish territory for vegetation seasons. So this is they developed this the Python code and methodology and data processing, which is available and here for this. And then you can see here that they also verified the results that they have been producing. And I just wanted to go through that. This is the final product that they have, this vegetation extent for local administrative units, which is from this 2017-2021. They've been with this, they create the vegetation extent, and then the other one they also created the vegetation condition for these local administrative units for between 2018 and 2021. And for Finnish use cases, we have two use cases. One is the snow statistics in Finland. So snow in Finland is very, important for us. This typically cover in October and May. And snow cover relates to spring flooding, hydropower industry, recreation, and so on, very important. And what is the point here that we wanted to use these statistics? Because in currently official statistics information deliver only one value and one day, which is the snow water equivalent at specific location in March 15. So this is the only one value. So we wanted to make this the more monthly and daily. So that's why that was the reason we started. And also we wanted to make this in a county level. So in Finland we have 19 counties here, and we just developed this. And also we create more statistics on this based. And we use lots of input data, as you see here, that Earth observation data, lots of, and then model, institute measurement, webcam, and reanalysis data, and so on. There are plenty of data has been used. So basically, what we developed that from the one day information to describe the whole country at regional level, so we can create many different statistics based on the needs, like such as regional differences, pointing out the extreme cases and years and annual differences. But these are our suggestion, and we talked about the Statistic Finland that whatever you need, we can have a look further develop this. So this was just quick showing that what can be done with this Earth observation data. Here you can see this the different years And on the graph A, you can see the minimum value of the snow load and the maximum value and mean snow load at this county level in March 2017. And then also we can show this, that the number of exceeding days of snow load of this, which we call this 100 kilogram of metric cube in the counties, because snow in Finland, I mean, snow load is very important because of infrastructure, houses, and so on, and also places. So we need one value that it will be known. Here, for instance, one of the statistics that we can create is that that number of days when snow load exceeds 100 kilogram meters in January. So then you can see that this where are the places and what should be done. The other one, for the flooding and everything, we create these snow melt off dates between 2001 and 2022. And here, so this has been long studies. Actually, this afternoon, I'm going to discuss this, how this research can be operational service. It has been long work. So we start, I mean, in Finland, this has been started in a long work, this snow study. Then we create this snow melt of dates, which is, you can see the statistic on average snow melt of dates for 19 Finnish counties that we can calculate for different years. So this type of stuff. The last one, the drought indicators in Finland. So we use these altimetry data for retrieving water level measures, because Sentinel-3, there's a product, water level product, river and lakes. You can have and use it, the global product. So we define this drought index using this water level of this product. And this, we define this hydrological drought index from water level variation, such things, formula. And then we calculate this for every month, this 12 months for the series of this, the averages. I mean, I'm going very practical way to explain. So then we create this, the cumulative distribution function of this values for each month. Then later on, we normalize this with the function, and then we can classify this as you see the states 1 to 7. So then the values are here. So then we can define this extremely wet, very wet, moderate wet, and status like this. Okay, so thank you very much. So I think I hope a few questions that I can have. Thanks a lot. That's all.
Thank you. Thank you so much, Dr. Arslan, for your excellent presentation on Earth observation and smart statistics, and for presenting the Gauss project to us. Thank you so much. At this point, I would like to ask the participants if there is any specific question for Dr. Arslan before closing the today invited talk. Dr. Christiana Babutsa.
Eliana, yes, I have one question actually. I don't know if maybe I will mute it.
Yeah, I made it.
Oh, you mute it. Okay. Thank you for the very interesting presentation. I wanted to ask about the in situ data that you mentioned that are also used together with the Earth observation data. So these are coming from stations that are located in all over the Europe.
You could please unmute Dr. Arslan so we can hear you. We can't hear you.
Yeah, I think question you heard, everybody heard correctly? Yeah.
The question from Christiana was clear. We didn't hear any of your answer. If you can please.
Okay, perfect. So basically every country has their own national institute data, such as in these cases. this it's a Gauss project that everybody use their own national institute data. But of course, as I said, that there is this EAA coordinating the institute data activity. So they are creating this the data portals where all these institute data needed for the Copernicus services. And institute data are used in two ways. One is the validating Calval activities of the satellite remote sensing products. And another way that you can also use institute data in developing the product in the product creation. So there are two ways of implementing this. Yeah. But institute data is a problem because in Finland we have a free and open strategy. So all these our institute data can be available. But in Poland, for instance, in government or some countries that they are actually not giving free, they are earning money. So that has been a problem. But of course, there are certain data is free for this available, but not all data. For instance, for us in Finland, all this country is free and meteorological data free and available, but it is not the case for all countries in Europe.
Thank you so much, Dr. Arslan. I think the invited talk has been finalized. Thank you all for your attention. And the invited talk will be uploaded on our YouTube channel, so anyone can check it again. Thank you so much. Goodbye.
Thank you very much. And in any further question, and any of you, please don't hesitate to contact me further.
Yes, you can contact Dr. Arslan directly, or you can send us an email and we can help you.
Thanks a lot.
Thank you so much, everyone. Thank you.
Bye.
Bye.